I want to go through a few more examples of antiderivatives in this slide, and what I've got up here right now is just those particular antiderivatives that I had in the last slide, and these are also in your textbook, and of course there's a lot more. Now what I want you to notice, we've looked at that third row, x to the n, and what its antiderivative is, sort of a reverse power rule. But notice that that does not apply if n is -1. So down the next row, x to the -1, remember, would be 1 over x. And notice what the antiderivative is. The natural log of the absolute value of x. And if you remember your derivatives, if you have the natural log of x, the derivative of that is 1 over x. So this makes perfect sense. So it's a special case. If you have x to the n, so x to any exponent except for -1, you use that reverse power rule. If n happens to be -1, then you have to remember the relationship with the natural log. Let's look at the function sine of x. What is the antiderivative? So what function do you have to take the derivative of to get sine of x? So now pause. All right, so did you dial back in your memory about the derivatives of trigonometric functions? So remember, if you take the derivative of the cosine of x, you're going to get negative sine of x. So we have to have negative cosine of x in order to get the derivative sine of x. So negative cosine of x is the antiderivative of sine of x, and to make it the most general, we're going to add an arbitrary constant. Because remember, when you take the derivative of any constant, you're going to get 0. So that c could be any number, anywhere, anytime, anyhow. F of x is equal to 1 over x, and actually we just looked at that example. Pause, come back. So the antiderivative of 1 over x is the natural log of absolute value of x plus your arbitrary constant. Now don't forget that. It's really easy to forget that arbitrary constant, but when you're asked to find the most general antiderivative, you're always going to add that arbitrary constant on. And x to the n, what's the antiderivative? Well, just look at your table. This is really the reverse power rule, the most generic. All right, how about cosine of x? So what do you take the derivative of to get cosine of x? Sine of x plus your arbitrary constant. And you know how you check your answers? Well, you just take the derivative of what you think the antiderivative of, and if you get your original question, then you're correct. So if we take the derivative of sine of x, yep, we get cosine of x. Perfect. How about, what did we have to take the derivative of to get 3 over x squared? So think about that. Did you come up with negative 3 over x plus c? So remember, 3 over x squared would be the same as 3x to the -2. So you're going to use that reverse power rule, add 1 to the exponent. So you're adding 1 to the -2, and then you're dividing by that new power. And let's look at this one. 2 times the cube root of x. What do you have to differentiate to get that? Did you get 3/2 times the cube root of x to the 4th? So the trick to this one is to convert that cube root of x to x to the 1/3, and now use your reverse power rule. So x to the 1/3, you're going to add 1 to the 1/3, so that's going to give you x to the 4/3, and then you're going to divide everything by that 4/3. So be careful with your fractions when you simplify that division, and you should come out with 3/2 times the cube root of x to the 4th plus your arbitrary constant. All right, more examples to come.